Another leap forward towards cleaner and more fuel-efficient aviation. This A340 took off from Toulouse on a beautiful fall day on its first test flight with totally newly designed wings that could eventually revolutionize air travel. The project, called BLADE, is a European Union-backed program to find ways of making flying even cleaner. Engineers from Airbus and its partners have been huddled together since 2008, developing the new wings called laminare wings, similar to what you get on gliders to reduce wing drag.
We are standing here in the A340 that has been modified for BLADE project. And the target of BLADE project is to bring into the air a new type of wing called the laminare wing, which aims at reducing aircraft drag and therefore fuel burn and fuel pollution. The wing drag is the fact that when you fly, the air is trying to slow you down, same as when you drive your car. And this is why we need engines on our aircraft to keep them going on. The less drag, the less power we need, and the less fuel consumption.
This animation gives you an idea of what happens when the air flows over the wing. Initially, it goes in a straight line, but then disperses in waves a little like a candle's fumes. The flow is turbulent, which leads to drag. The idea is to make the wind flow smooth and more efficient. The long-term aim of the BLADE project is to reduce fuel burn by as much as 5%. For the aviation industry, that would be great news, especially when you consider that fuel can be up to 40% of an airline's operating costs.
Generally speaking, the fuel burn is really important for the airlines. This is a major part of their overall cost structure for operating our aircraft. So any solution that helps reducing this cost is very important, I guess, for them and so for us.
For the next 18 months, the team behind the BLADE project will analyze all the data from the flights on the A340 to get as close to that 5% reduction as possible.
This instrumentation is looking at the wing, at the pattern on the wing, and the important thing is its reflection, which you see here. By looking at this reflection, we are able to see the status of the wing surface. Those lines here are not perfectly straight. It means that the reflection has some imperfections, and we have partners which are able to use that data to post-compute what was the initial deformation. And this is very important to know what is the surface state of the wing and to understand the aerodynamic flow which is then above.
While the BLADE project is relying on the A340 for the tests, Airbus has far greater ambitions.
Indeed, the first objective for this type of technology is an introduction on single-aisle type of aircraft. But over the long term, this is also our intention and ambition to deploy laminar flow on long-range type of aircraft, such as A350 or A380. But this will require some extrapolation of these results, but also some further technology development, because there are technical specificities with long-range aircraft, higher speeds, that require some additional technology development. And we are working on this also.
You saw these laminar wings here first, but within 15 years from now, they could be commonplace on your journey.